Okay, so this is Trigonometry 2, so it's second semester Trigonometry, fundamental identities. Now, I'm going to teach you guys how to do this, and it's really easy if you remember a couple things. So, sine, do you remember what sine is supposed to be? Y over R, right? And what is R always going to be when I'm dealing with certain things? 1. So identities and dealing with unit circle, my R is always 1, right?
Yes.
So it's going to be that. Then cosine would be X over R. So, and it's usually R is 1, right? Tangent Y over X. Tangent is Y over X. Cotangent X over Y. Secant
Y over R over Y.
R over X. Secant is R over X. And cosecant is R over Y. So going through those, okay, a lot of these things. So if we know them for what they are, we know this is sine is my Y, right? So I'm going to just treat it like it's the Y by itself. So sine, if my, come on. Why are you yellow now? There we go. Okay. Y, X, X, Y. So the first identity we're actually going to deal with here is this thing right here. And I'm going to show you guys why that works out. So cosine times tangent. Okay. Cosine, we said, is what over what? X over R. And what is my R going to be? 1. R is going to be 1. R is going to be 1. So I'm going to say that this is going to be X over 1 times. What did I say tangent is? Y over X. What's going to happen right there? Very good. X's cancel out. So this is what I was saying about this becomes easy because this just turns into Y and Y over 1. And so Y over 1 is? Nope. Sine. Thank you. That's what I'm looking for. Wrong one. That one. See, cosine times tangent is going to give me sine. Okay, so sine times cotangent. So sine, cotangent, right? So let's translate it. Sine is Y over 1. My R is going to be 1 for all my identities. R is going to be 1. Times cotangent. X over Y. X over Y. Y's cancel out. That's what I needed. Just X, which comes out to be cosine of X. X over 1, right? Which is just cosine. This is what I was talking about. It comes out easy as long as you pay attention to a couple fundamental things. All right. Okay, Pythagorean identities. Let's take a look at the Pythagorean identities. There you go. Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Isn't this the same as saying y squared plus x squared equals 1 squared? Which is the same as saying a squared plus b squared equals c squared, because the radius of my unit circle is always 1. The radius of my unit circle is always going to be 1. So that's going to give me this value. The c is always going to be 1. So in my triangle, which comes from here, I have a y value here, I have an x value here, and this is my r value. So, and this is my point x comma y. There we go, x comma y, there we go. So it's always going to be like this. It's always going to be like this. So my x squared plus y squared is equal to r squared, but my r on my unit circle is always going to be 1. So that's where I get this one. My x squared, so it's my cosine squared, plus my sine squared is equal to 1. Now let's take a look at this. So I'm going to rewrite this. Y squared plus x squared equals 1. Okay, I'm going to teach you guys how to actually derive all those formulas just by looking at this. Now, what does x represent? Cosine. X is my cosine, right? Let's divide everything by x squared. Dividing everything. Divide both sides of the equation by x squared. Okay? Now, this is one thing that I'm going to end up with. So what is y over x? Tangent. It's tangent, isn't it? Y over x is tangent. This is refresher. I know, you guys lost a lot of this over break. Y over x is tangent, right? So isn't this the same as saying tangent squared? So tangent squared, right? Because it's square, square, tangent squared. Okay, what is x squared divided by x squared? 1. Now, what is 1 over x? Secant. That one's secant, right? But what if it's 1 over x squared? Secant squared. Close that one too.
Is that the final?
There we go. So we come up with this one right here. So tangent squared plus 1 is equal to secant squared. I took my first identity, I divided everything by x squared. Now what do you think I'm going to do next? I just divided everything by x squared. What should I do now?
Divide everything by y squared.
Excellent. Y squared. What is y squared over y squared? 1 plus. What is x over y?
Cotangent.
Cotangent, right? Cotangent. Now it's x squared over y squared, so that's going to be. And 1 over y is cosecant. 1 over y is cosecant, so 1 over y squared is cosecant squared. We just made all 3 of these. Don't worry about this one right here. This one right here just confuses even me. I hate trying to even do this.
What, the last one? Or the bottom?
This negative angle identities, don't worry about that. It's, don't. Because there's restrictions on these, it's better to just do the math to figure out where it's at.
Oh, so you're not going to give us problems using those?
No, like I said, it's do the math, figure out where it's at. If I say it's supposed to be in quadrant 2, sign has to be
Oh,
positive, right?
Yeah.
Okay, so it's basically getting stuff like that.
Oh, okay, cool.
Can be angle in degrees, a real number, or a variable. Okay, so for this right here, tan theta is negative 5 over 3. It's in quadrant 2. Find the function, each function value. Okay, what do we say tan is?
Uh,
Tangent is y over x, right? So y, and I have x. So what's the third thing that I have to find? X, y, and r. We did these problems already. This is just a refresher on this. We have x, y, and r. So now it says it's in quadrant 2. I'm going to draw a little circle. Here's my quadrant 2. This is plus, plus. This is minus, plus, minus, minus, and plus, minus. So in quadrant 2, which one is negative?
X.
X is negative. So what am I going to write for my y value here?
5.
What am I writing for my x value?
Negative 3.
How do I find the r?
Pythagorean Theorem.
Pythagorean Theorem, right? So r is equal to the square root of x squared plus y squared, right? So negative 3 squared plus 5 squared. So it's 9 plus 25.
This is 34. It's 5.83.
Square root of 34. Leave it as that.
Okay.
Leave it as that. Because all of our fractions, it's easier to do our fractions if we have just the radical. The only thing that we're going to have to do is just rationalize. All right. Find each function value. Is it on the next page or is it this page? Okay. So, wait, what? There we go. So, what is sine going to be?
Y over R.
Y over R. Y over R. So what was my y value?
5.
What is the R value?
Hold up, mister.
Square root of 34.
There we go.
Hold up, mister. Oh, that's all we're doing?
Yeah, just those. It's actually, there's 2 of them, I think, right?
You can't have that in the bottom.
We cannot have it, right?
Rationalize.
We have to rationalize. Very good. We have to rationalize. We can't have a radical in the bottom, so I'm going to rationalize. Multiply top and bottom by rad 34, which is going to give me 5 rad 34 over 34 as my answer.
Oh, this is not hard. So what?
It's not.
Oh, and then we're doing the same thing for secant is
Okay.
X over R, right?
So this next one is cotangent, right? Next one's cotangent, isn't it?
X over Y.
That says cotangent of a negative angle, though. Negative angle. So if it's supposed to be in quadrant 2,
It's in quadrant 4.
let's take a look. So if my angle starts off and goes somewhere to quadrant 2, right? Let's say it goes to right here. Let's say it goes to right here. If I would go backwards on that, instead of going this way, the negative angle would put me which way?
Counterclockwise.
Counterclockwise. So I would go the same distance, but going backwards, right?
Yeah.
Oh.
So going backwards would put me where? Quadrant what? 3, right here. Quadrant 3, because I'm going the same distance, I'm just going in the other direction. Okay. So in that direction, I know that the x value and the y value both have to be negative, right? Okay, x value and y value both have to be negative, so cotangent is something over something. What is cotangent?
Oh, X over Y.
X over y. Cotangent is x over y. So my x value, we said has to be a negative. That would be what?
It was
Negative
negative 3.
3, right?
Negative 3 over 5.
Oh, okay. And then the y value is? But is it in quadrant 3 now?
No.
It's in quadrant 3 now, isn't it? because this one right here changed my angle. It's no longer in quadrant 2. It's now in quadrant 3. That's what that means. When I said do the math on it, figure out where it's supposed to be located at, instead of actually going and doing like the little tricks. Okay, so negative makes a.
Positive 3 over 5.
So if I go back to my thing right here. So, did it make it positive?
Yeah.
It's easier to just do the math on it.
Mister, is sine and cosecant are the opposite of each other?
Yes,
Okay.
reciprocals. It's on the first page or second page.
I just forgot.
It's right there. Page 2. All right, so I'm trying to see if I need, I think I'm supposed to do 2. Okay, write cosine in terms of tangent x. Okay. Cosine in terms of tangent x. Okay, so since secant x is related to both cosine and tangent by this identity, so everything we're going to do here is manipulating. Okay, so I'm going to change this up. So I want tangent, so that means that's what I want. I want to see tangents, and I want to say cosine equals. That's the point of what I'm trying to do right now. I want to make this say cosine equals. Let's change this. 1 plus tangent squared x equals 1 over cosine squared x. What did I just end up doing right there? Yep, change secant to cosine, right? Change secant to 1 over cosine. It's the same thing what we had earlier, right? Okay. So now, I do not want it to say 1 over cosine. I want it to just say cosine, right? How would I get the cosine out of the bottom?
Multiply by 1. Oh.
By
Cosine.
cosine squared, right? Okay, this is going to cancel. So I'm left with cosine squared x times 1 plus tangent squared x is equal to 1. I'm almost there. I got to get rid of my 1 plus tangent squared, right? I got to get rid of that, right? What's happening to it right now? Is it multiplying? Say yes.
Yes.
It's multiplying. How do I undo a multiplication?
Divide.
Divide. So I'm going to divide both sides by, not cosine.
1 plus tangent squared x.
Very good. 1 plus tangent squared x. That's why I put it in parentheses here. So 1. So I cancel these. I get cosine squared x is equal to 1 over 1 plus tangent squared x. Am I there yet?
No.
What's wrong?
Used to have an X.
Nope.
That's on the bottom?
Nope. Look at this.
Cosine squared x.
Oh, it's not secant.
It's not.
It's
It's still squared.
You need to get rid of it.
There we go. That's what I'm looking for. It's still squared, isn't it? It's still squared, and I don't want it squared. How do I undo a square? Square root. So I square root both sides, right?
Yes.
So my answer is going to be cosine x is equal to the square root. So it's actually a plus or minus square root 1 over tangent squared x. So here, let me put a little box around this and write A and S. There we go.
Is that it?
It's not bad. I'm hoping you guys could actually work with this. The information I gave you right now, what's the most important thing that you guys got to remember?
R equals 1.
R equals 1, your X, Y's, and R's, right? That's it. I'm going to give you guys the rest of this time I need you actually working on this.
This is what you said was